Now we want a rectangle that's underneath or inscribed under this parabola. So here's the parabola. You know that it's up here at 12. So the rectangle that they're talking about is this rectangle here, where the edges of the rectangle touch the parabola, and then the bottom of it is sitting on the x-axis. So you know that the area of a rectangle is length times height, right? Or length times width, whatever you want to think of it. I'm just going to use height. So you know that the length of this will be this distance right here, right? And so I'll call that L. And then the height of it will be here. So the length, let's think about that. Won't this be some x value? And won't that be the same x value but in the opposite direction? So negative x. So that means the length will be 2x. So that's going to be used often. So you want to make sure you understand that. X and the distance of x, right? Because we're talking about a rectangle, so it's got to be a positive distance. So my length I can replace with 2x. Let's think about our height. Height is from here to here. Wait a minute, doesn't that touch the function? So won't the height equal the y value? And so the height is the y value, so I'm going to put in the function, 12 minus x squared. So there it is. That's the area formula that I want to find the largest of. So that means I want to take the derivative of that and set it equal to 0. Again, I'm going to take the time to multiply this out. So this gives me 24x minus 2x cubed. Take the derivative, 24 minus 6x squared, set it equal to 0. 6x squared, so if I divide by 6, I get 4. And so I get plus or minus 2. All right, that kind of makes sense. That makes sense. So we have the same number for the x's, right? So if let's see, dimensions of the rectangle. So the length of the rectangle, the way I've labeled it, would be 2 times 2, or 4, right? And what would the height of my rectangle be? The height will be me plugging in 2 into here, right? So 12 minus 2 squared, which is 4, which would give me 8. Okay, same problem, just a little more challenging. Now I'm making my inscribed rectangle fit underneath this half circle. So again, the the edges of the rectangle have to only go up as high as that. So that's the y value. And then the length, right, that would be the y value, that's the height. The length will be again 2 of those x's. So area is 2x, right, length, times the height, which is the y value, so that's this function. Oh, can't separate that or anything. I just need to do product rule. So first, okay, this is tricky. Be careful. 1/2 comes down. Don't forget the negative 1/2. Remember, that was such an easy thing to forget. Carry the inside along. And then multiply by the derivative of the inside, so that's negative 2x. Plus second d first. So that's going to give me 2, 9 minus x squared. Okay, let's see what we got. So I want to take the time to simplify. So let me get rid of that so I can have room here. Whoops, and I meant to say that this is a prime, right? So a prime equals, okay, let's spend some time simplifying. So this negative 2x, that 2, and that 2x. So let's see, if I cancel these 2's, I'd get an x and a negative 2x. So that gives me a negative 2x squared. Next, I'm going to take the time to put this term in the denominator because it's got a negative exponent. So that's 9 minus x squared. Okay, then this term just carries along for the ride. Plus 2 root 9 minus x squared. All right, I want to set this equal to 0 to find the critical numbers, right? So if I set this equal to 0, how about if I move this negative term to the other side? So I get 2, 9 minus x squared equals 2x squared root 9 minus x squared. All right, let's see what we got going on here. I see that I can cancel 2's right away. The next thing I'm going to do is I'm going to multiply both sides by root 9 minus x squared. These two will cancel, so I'll just be left with an x squared on this side. When I multiply this radical times this radical, I get 9 minus x squared. Oh, I can add x squared over, so I get 9 equals 2x squared. So 9 over 2 is x squared. So what does that tell me? X is equal to plus or minus 3 over root 2. So that's the x value. And can you find the y value by putting it back into here? Sure can. So I would get y is equal to square root of 9 minus, and that would be like 9 halves. And that would be the y value.